Well, hi, good morning. Thanks so much for joining me here in my shop. Today I'm going to be starting just what you see on the screen there. Preliminary tests and plate bridge balance, whatever the heck that is. So I've decided probably the best way for me to proceed through here is to follow through the instructions that were provided to the kit builders who potentially built this. This may have been factory built or may have been built as a kit. I don't know yet. I don't know if I'll ever know. But the thing is, if it's built as a kit, then there's a fairly detailed procedure once you've finished building it in starting it up. And because, of course, chances are a kit builder has made a number of mistakes in building something as complicated as this. I mean, really, if you think you can build something like this and not have a mistake in it. So I don't think there's any mistakes in here. There could be some bad parts, some resistors that have gone off or something like that. And so what I'm hoping is just going through the calibration process is going to highlight some of these things and lead me to where I need to go to make repairs in it or something of that sort. So I'm just going to follow it line by line. You'll see the lines at the top of your screen. I have a full screen view of the manual here. Let's just go down a little bit here on it. Look at that. You've now completed the wiring of your Model 111. Somebody did. A few more tests and adjustments and the instrument may become part of your laboratory. Well, what do they mean, may? I don't think there's any doubt this is going to become part of my laboratory. Well, I like to call it a shop. But this gives you an idea right off the bat that the guy who designed this saw it as a laboratory device. And in fact, in here it's written somewhere in here in this manual, the suggestion that this is much more than just your typical tube tester, if there is such a thing. So, wiring check. Okay, so we can assume that the wiring has been checked and we've operated this machine already. Operational procedure. When you have completed the various checks and are certain that all the wiring is proper, proceed as follows. This is what I want to do right here. All internal controls on the power supply chassis should be set to their maximum clockwise position. So this is the first step here. Shaft type. Now I got to think about this because these instructions are written for someone who just built this unit. Mine has been through this process years and years ago, assumably, and is already properly adjusted to a large degree. So really, I'm not starting from scratch here. I'm in a refinement mode. Do I dare go and turn all these controls to their clockwise position to start? Or should I leave them in what is probably pretty much the correct position right now? This is a tough choice. There's a chance that these instructions are depending upon one of these controls being in its clockwise position for these instructions to work. I did read through the instructions already. I didn't see anything like that actually that would make me think that. So one thing's for sure, if I turn all these controls to their maximum clockwise position, I won't be able to return them to where they are now unless I take a lot of steps to enable me to return them back. I think the best thing I can do is leave all these rheostats and adjustments as they are on the assumption that they're all pretty much in the right place. And in fact, if I come across one in the course of doing all this, one adjustment that seems to require a lot of adjustment, that might hint to me that some component has drifted since the first time the thing was adjusted, was calibrated. Okay, so I think that's clear in my mind now what I want to do, at least for the next sentence. Let's see. Shaft type controls. Okay, so this is telling you how to recognize which way is counterclockwise. Was it counterclockwise or clockwise? Clockwise. Set all front panel controls and switches as follows. Okay, so I can do this part here. Controls A through, is that O or is that 0? A through O, bias, filament, and meter to their extreme counterclockwise this time. Counterclockwise position. All controls A through O, that's all these, counterclockwise. Think I was using this as a supply of knobs for other devices. That's why these knobs were missing here earlier. I had taken them off and put them on other things. That's how much I thought this guy was a complete write-off. How foolish of me. Well, what about these ones too? Meter, short, what's it say about those? Filament and meter. Filament and meter. It's online now. What about this one? Well, I have this one. You know what? There is no maximum clockwise position on this because it just goes around and around and around. We'll leave it on test. Wait a minute, clockwise? No, counterclockwise. That's how easy it is. Bias. I think everything is set counterclockwise now. How am I ever going to make it through this? Test switch to hold line potentiometer to mid rotation. Oh, I haven't put a knob on the line one yet. Well, the line one's already mid rotation. This one they want on hold. So I have the plug out, so there's no concerns here. As I thought I left it on here. Let's put that off. I think that should probably be off. Test switch to hold line potential mid rotation. Short switch to test. Short switch. That's this one to test. Okay. Bias slide switch to 10 volt range. That's that. Off. A light on switch to off. I just did that. Check the resistance. Oh, here we go. Check the resistance from terminal 16. Now, should I do this? These are gross tests to see if you've made some kind of wiring error in here. It's really what these tests are looking for. Big bad problem. Yeah, check the wiring of these things. So again, I can go on the assumption that this must all be correct. Why would I think otherwise? So terminal 16 of PT4. Should we go through the process of trying to? What is power transformer 4? I'm going to stay away from this test because I don't know. I'm going to stay away from this test. Let's do this one though. This is easier. Pin 7 of the 7-pin miniature socket. H61. This should be approximately 8,000 ohms of low resistance is read. Check all this wiring. Well, we can do this one. Check the resistance to ground from pin 7. Resistance to ground, pin 7. Pin 7 of this tube. Pin 7, eh? Let's see. So that's a 7-pin. 7 has this big resistor on it. The unit has not been turned on today. It's not plugged in. And this is just to the chassis here. Oh, I've got the wrong meter in my hand. Well, it's okay. I can do it. Do it with this one. It's got an ohmmeter in it. This is 10, it's reading 10K. Yeah, 10K. Now what's it supposed to be? At least 50,000 ohms. Oh, no, that's the wrong one. There should be approximately 8,000 if a lower resistance is read. So we're at 10K, so that's okay. 10K is okay. Now I got the ohmmeter out and everything. Why don't we try this other one? So the pin 16 of PT4. What is PT4? What is PT4? Okay, I'm just going to shoot around the manual here quickly. You're just going to see a little slice of it up there. PT4. Here's PT3. PT4. So PT4 is the transformer that's hooked up to the which tube? Oh, you're not going to put the tube name on here? So I'm looking, sorry, let me get this on the screen where you can see it. So there's PT4 here. Which tube is this? Come on. It doesn't tell me. Really? Well, PT4. How else can I figure out PT4? Yeah, I should give a little call out to BAMA. That's where I got this. This is the Boat Anchor Manual Archive. There it is there. Boat Anchor Manual Archive. Thank you for all this. But why not tell me which one is P4? Maybe it's written on here. Maybe somebody wrote it right on the chassis here. Wrote it right. There's a lot of stuff written on here. But of course that's not written on there. Okay, so let's see. These transformers look fairly different. 1, 2, 3, 4. So this has got many outputs. This one, not so many. So this is the I don't know. I was going to say probably this is the heater one. Let's look down here. PT3. PT4. Yeah, that's right. What am I reacting for? PT3. So PT3 is all the taps for the different heater voltages. 19 of them on the output, and the other transformer has 1, 2, 3, 4, 5, 6, 7, 8, about 10 versus 19. If I look again here, well, this is 10, this is 19. Okay. Kind of forgot what I'm up to here entirely. So this is. I've lost my mind. So having measured the resistance, let's get this off here. Having not measured the resistance, because I'm still trying to figure it out. So now we know this is PT4. Which terminal is the one I'm supposed to get on? What did it say in the instructions again? Check resistance from terminal 16 to ground. Terminal 16. How am I going to know? They're numbered. There are numbers on there. Just make sure I've got this. Here we are. Check resistance to ground from pin number 7. Wait a minute. Wait a minute. Just a little hard to move my screen here just the way I want it. There we are. Check the resistance at terminal 16. 16. So I can see some numbers here. 6, 5, 4, 1, 7, 17. One, 2, 3, 4, 5. There's 17. Oh my gosh, did that say 7? 3, 4, 5, 6, 7? 17? These aren't in order? 2, 7, 17. Wow, 15, 2, 7, 17. How do you like that? I saw 17, I figured this one must be 16, but oh no. Oh no. Here's my little mirror. Let's use the camera here and see if we can see these things in the camera. Okay, sit right there. I have to fix the focus. Oh, this might take a moment here, I'm afraid. Just bear with me here while I fight with my computer a little bit. Okay, here we go. Let's focus this guy here. So I can read the numbers there. 8, 9, 8, 9. Okay, maybe it's down in the lower part. Let's see. There's 16 right there. Definitely 16. That blue wire. Yeah, I don't think I want to chase that through this machine. But was there a terminal down there? It's way down under there. Oh yeah. Where's that black wire going to the capacitor? Is that right from that same pin? It would look that way, doesn't it? So 16 is grounded by a little 0.01. According to that. Okay. Let's measure the resistance to ground there. $230K. What's it saying? It should be at least 50,000. Well, it's way above 50,000. Yeah, 230K. What can I tell you? It's way above 50,000. Of course, that's 50,000 with all these. See, aha, this is probably a test that is dependent on all those controls being turned clockwise. Was it clockwise? And I didn't do it. And that could be why this test shows much higher than anticipated. Now, the question is, did that cover up a fault? I don't think so. I don't think I'm looking at a gross fault in this machine. So, okay, so we're going to accept it. If it was under 50,000, then I'd be jumping up and down, but I'm going to do that. So now, we've done the 50,000 at least. We've done the 8,000. Connect AC voltmeter from ground terminal to terminal 14. Oh, I got to go looking for more terminals here. 14. AC voltmeter. I think I'm gonna stick with not using a VTVM for this because of just the chance of a grounding deal going on. I don't want a grounding deal. So we'll set this guy up to read AC volts. AC volts. Connected where? Connected terminal 14 at PT4. So 14. Did anybody spot 14 while I was doing that? Look around. Yeah, look around some more. 14. Let's see. $16, $10. Let me turn this camera the other way here. If I hold the camera on a funny angle, instead of the normal way you would hold a camera, then moving it around becomes a nightmare for me. Looks like 10, 12. I see a 4 on the yellow one. Got a little more light in here, right? 16, 10. Darn blue wire. Maybe 14 is somewhere where I can find it easily somewhere else. 7, 20 something. 15, not 14. See, they put these wires right in front of the numbers here. These ones here. And these ones here. 8, 9. Is that 13 there? It's the simplest thing in the world to read these numbers, you'd think. Oh, wait a minute, I can almost read that number there. Come on, camera. 14 on the yellow. Yellow wire is 14. Oh, jeepers. 14. Microtran. That's the name of the manufacturer of the... Well, 14 on the yellow. Yellow wire is 14. I'm pretty sure I got it there. Pretty sure. 14. And what are we doing with it now that I found it? We're going to set up an AC voltage test. Right. Sounds like we're going to turn this guy on very soon. That's 14. And what do we do about it after we read it? Use a range of at least 10 volts. Plug the line cord into any outlets. Push the slide switch on. Pilot light should light immediately. If it does not, turn it off at once. And check and see what's going wrong. Otherwise, set line adjust control on front panel for a 5 volt. Set line adjust control on front panel for a 5 volt reading. Without changing any of the settings, adjust internal line. Is it for what? For a center scale reading on the tube tester. Right, so we're reading 5 volts first on this external meter, and then we're doing the internal adjustment to bring the panel meter up to the center point. Okay, I think we're ready. Plug this in. Got anything else connected to it? That would be a consideration here. I don't think so. Nothing else. Plug it in. I did. Push the slide switch to on. Now we don't have power in here just yet, but let's do that. Slide switch to on. It's on. We'll apply power now. Adjust line adjust control on front panel for 5 volt reading. Okay, I think I'm missing a knob on the front here. It's the one control I don't have a knob on. It's pretty easy to turn though. Okay, I won't bother with the knob just now. We're all set. Power on. First using dim lights. The dim lights came on. We got pretty close to 5 volts here now. Of course, I have no idea if this is... That's right, I'm supposed to adjust this to get 5 there. I can see the line meter is right in the middle up here. The line adjust. The line meter reading. Yeah. Okay, so we turn this to get 5 here. Oh, it's way off. There we go. So this isn't working out well. I don't like this idea. This control has reached its limit. Oh, you know what? I don't have full power on. Back. That's right. Don't adjust the line voltage with fake line voltage. 110. Okay, that is a little better. We're now using 123. That's a little better. Wow, I almost made a big mistake there. Adjust this for 5. How close are we to the edge? Long ways from the edge. I wanted to jump out there and take a look. Okay, adjust for 5. Just a little more precision here. You can imagine back in the day when they were doing this, their meter, when it said 5 volts, it was 5 volts plus or minus 10%. This one's going to be way more accurate, I would imagine. 5 volts. Now we need to adjust the front panel meter so that it's centered. That's what we're going to try to do. But I have to find out what's the adjustment now. Adjust the internal line potential, line potentiometer P9 located on the power supply chassis. Located on the power supply chassis. This must be the power supply chassis, I'm going to guess, because it's got the 2 rectifier tubes on it. That doesn't help much. There's an awful lot of adjustments on the power supply panel. P9. I'm looking at too many things at once here. P9. Hey, maybe he wrote it upon there. He may have done that. Whoever he was, he may have built this thing. So he seemed to pencil a lot of stuff up, but none of these are marked. It's just leaping out at me here somehow. The meter movement is up in here. That could be any one of these. Okay, I'm going to have to run around the manual here. So you're just going to see a little slice of it up there. Oh, here we are. You're going to have to go far. 13, 12, 11, 14, P9. So P9 is right in the middle of this set of stuff here. P9, let me look over. Look over and make sure I'm seeing it for what it is. P9 is that guy right there. That's the guy. That's the guy right there. P9. So the objective now is to use P9 right below the tube. P9 to set the panel meter dead center. Okay, we've got the 5 volt AC reading up. It's hanging in there just fine. Without changing any above setting, adjust the internal line P9 for a center reading of yes. For a center reading of yes. Okay, this may not be the best meter display you've seen here. There we go. Hey, you know what? I can correct the. Just grab this and elevate my camera a little bit. Maybe even lay it on its side. Wow, look at that. Excellent. So we want to center that up right on the 10. And I want to do that by adjusting P9. P9 is that one we found. Here it is. This is P9. Oh goody. Well, that's the wrong way. 9. Now, so when this is centered like this, there'll be 5 volts at that point, at that test point, which obviously the designers know if there's 5 volts there, there's something else correct everywhere else. So, yeah, that's kind of neat. Oh, that's kind of cool. I could have left it like that. That's pretty cool looking. I'm admiring my video screen there. So we actually did one. I actually did something to this machine. Wow. Without changing any settings, and we might as well go right down to here where it says plate bridge balance. So I'll finish this off. Without changing any settings, connect an AC voltmeter VTVM between chassis ground and terminal number 2 of P5. Adjust for 2.4 volts. If it's not, if an AC VTVM is not available, well, I do have one. How accurate is it? So they want you to use the VTVM because it's very high impedance, and my little meter is high impedance. So I think I'm just going to continue using the little meter and not use the VTVM on this because the AC scales are not that accurate on my VTVMs. And this is a low voltage here, and they want some precision in it. Okay, so where are we hooking it up again? P9, oh, that's up there, down here. Terminal 2 center arm of P5. So we got to find P5. I can go up here and take a look for P5, P5A, and P5. So here's P5, and the center terminal would be number 2 right there. Okay, so I'll take a look now. There's P5 right there at the top. Center terminal. Let's look. Sorry, I'm just confused by my own computer finagling here. So many complications. Okay, how's that? Without? No? That's good for now. Without changing it, connect the AC voltmeter to the terminal 2 of P2. Okay, so, oh, son of a gun now. there's 2 here and there's 2 here. I think it's these ones. You know what? I can't tell. I cannot tell for sure. I gotta look back at the. Come on. This is a stupid meter at this point for me anyway, because it's telling me it's going to turn off. So I'm going to turn it off myself and turn it back on. You know, why doesn't it just have a little, maybe any button would just keep it going. Any button, try any button. I don't know, I think I just put it into hold mode. But what a hassle. You turn it off, you don't want to snap it past these scales without pulling one of the leads out. I mean, the whole thing is a hassle. See, I don't normally complain, but I'm complaining now. Look what's happened. It's on hold. I don't want it on hold. You got off hold. The problems we face in life. They're so horrible. Now, try to focus a little bit here. I'm going to put this voltmeter somewhere else. I'll tell you where I'm going to put it. I'm going to put it up here. Wasn't I going to check and make sure this was the right one? I am. I'm still going to do that. You know what? I think... Just leave that there. Let's check. Let me check. Check with the schematic here. Oh. Okay, enough of that crazy stuff. It's not really the schematic I wanted to look at, is it? It's that diagram. Come on. You know, I've been in here too long. So this looks like the top, bottom, just making absolutely sure I got it right. 2, 3. This is PT4. I do not have it right. I have it actually reversed around. So P9 is still P9, but this is not. This is throwing me off here. So PT4. There should be a little. Can't see it here. There's a little transformer on the back. PT4 has. PT4 has a smaller tube next to it. Right. PT5 mounts on other side. That's exactly right. Okay, so I know where I am. I was at the wrong end. I was at the wrong end of this panel. About to hook up to here. But this is actually down here. This is P5. Pictorially. Okay, did I confuse everybody? Because I thoroughly confused myself. Okay, glad I kind of checked out. I'm going to get this in under there now. The unit's on. Okay, I can tip it a fair bit safely. I have to push against the weight of this transformer. Oh, I don't like this. Clip it on here. I don't like it. I don't like this at all. Okay, and I'm going to stop because I'm holding on to the chassis with my hand here. I'm breaking every rule in the book. Power off. You just can't anticipate, how you might make an accidental contact. This thing could, this thing could rotate a little bit and make a spark, and the spark could scare me enough to drop the whole machine and, call for my cat. Okay, let's see. Oh boy. I think that's okay. I think that's clipped in there okay. We're on again. So this is supposed to be adjusted to 2.8 volts AC. Okay, let's give it the full shot. Pretty darn close, isn't it? The adjustment now for that, well, what am I adjusting? It says meter. Adjust center arm of P5, so you must be adjusting P5. Okay, that makes sense. P5 is down here. And we're looking for 2.8. Tiny movements here. Going the wrong way? Yep, going the wrong way, Jim. 2.8 is the other way. That's about as close as I could possibly get. I mean, I'm working on the third decimal point here. Great. Okay, so that's done. Next. If you don't have it, use an ohmmeter this way. Okay, I don't want to do that. I don't want to do that. More accurate adjustment would be to first measure the total. Yeah, I don't need to do any of that. It's really written by an engineer for engineers, this manual. Like he's throwing little hints out. Hey, by the way, if you're smart enough, you could do this. A conventional 1000 ohm minute. Remove the VTVM when finished. Yeah, power off. So I think we've reached the end of the first little bit here. Get that off of there. Put this back. I think. And that multiplied by 0.56. P5, of course, should be measured with the lead P5 number 1 removed. Of course. That's written for an engineer. It's engineer talking to engineer here. A conventional 1000 ohm is not recommended. Not good enough. Okay, that's fine. So that's what's next. Plate bridge balance. That's what's coming. GM adjustment. That's coming. Screen balance. I think I'm just going to take each one of these one at a time until we get all the way through this process. So there we are. Plate bridge balance. Whoop. It's not showing up there. There we are. Plate bridge balance. So that's for the next video. Not for the next video. It's for the next video. So thanks so much for watching, and well, I'll see you on the next one.